In this video, we'll be going over find the duplicate number. So given an array of integers, nums, containing n plus 1 integers, where each integer is in the range of 1 to n inclusive. This means all of the integers are within the range. So there's only one repeated number in nums. Return this repeated number. So in our first example, we're given this array 1, 3, 4, 2, and 2. And then we need to return 2 because it's a duplicate number. In our second example, we have 3, 1, 3, 4, 2. And then we need to return to 3 because 3 is a duplicate number. Let's draw a simple diagram for this, and then we can see a pattern with this question. So we can represent each of the numbers as a node. So let's create a few nodes. Then we have the numbers 1, 3, 4, and 2. And then we draw an arrow between them. We get this list. Now let's draw out the second example. We have 3, 1, 4, and 2. Now we need to draw 3 to 1, 1 to 3, and then 3 to 4, and then 4 to 2. We can see a pattern here is that when there's a duplicate number, we can see that there's a cycle inside our list. As we can see here, there's always a cycle here. And now the duplicate number is always located at the start of the cycle. As we can see here, this is the start of the cycle, so we get here. And over here is the start of the cycle. And then we have number 3, that's a duplicate number. Now let's go over the dot process. So now this becomes, we are searching for the start node of a cycle inside a list. Now this becomes, we can find the cycle or the start node of a cycle using Floyd's cycle detection algorithm. Now in the algorithm, we will have 2 pointers, which is our slow and our fast pointer. So the fast pointer moves forward 2 steps at a time. The slow pointer moves forward 1 step at a time. When the fast pointer or when the slow pointer catches up to the fast pointer, this means we have reached, we are currently inside a cycle. Now, how can we detect the start of a cycle instead? So let's first denote the length from the start of the list to the cycle is equal to k. And then let's denote the length of the cycle is equal to n. When the slow pointer reaches the start of the cycle, the fast pointer, since it moves 2 steps at a time, the fast pointer will already be k steps into the cycle, which is a distance of m minus k steps away from the slow cycle. Now, since the fast pointer always catches up to the slow pointer one step at a time, the fast pointer will catch up in m minus k steps. Now this means when the fast pointer is equal to the slow pointer, they will both be n minus k steps into the cycle. Now this is which is k steps from the start of the cycle. Now we need to find a way to move k steps. This will allow us to get to the start of the cycle. We should note that the length from the start of the list to the cycle is equal to k. This means we can move the slow pointer back to the start of the list. We can move the slow pointer back to the start of the list. Then move both pointers one step at a time. When both of the pointers meet, they will be both at the start of the cycle. Now let's go over the pseudocode. So we're going to create two variables, the slow and the fast pointer, so moves one step at a time. Then the fast moves 2 steps at a time. Now, perform a do while loop. So perform the loop while the slow pointer is not equal to the fast pointer. So perform a do while loop with slow not equal to fast. So we're going to set slow to nums slow, move it 1 step. So and then we're going to set fast to nums fast, move it 2 steps. Now after they meet, there will be k minus 1 steps into the cycle, which is k steps from the start of the cycle. We want to move our slow pointer back to the start of the list again. So I'm going to set slow to 0, which is our start. And then while slow is not equal to fast, we want to move them 1 step at a time. So I'm going to set slow to move in 1 step, num slow. And I'm going to set fast also 1 step to nums fast. And then we can just return slow, which is the start of the list, which is our duplicate number. Now let's go over the time and space complexity. So the time complexity is of n, where n is the length of the input array. This is our 2-pointer approach. And our space complexity is of 1. Now let's go over the code. So we're going to create 2 variables, slow and fast, initially at the start of the list. So perform a do while loop, move slow 1 step at a time, and then move fast 2 steps at a time. And then want to move the slow pointer back to the start of the list after both of the pointers are inside the cycle. And then want to move them 1 step at a time until they have reached each other, which is at the start of the cycle. Then I want to move slow 1 step, and then want to move fast 1 step. Then we can return slow. Let me know if any questions in the comment section below.